Okay, so in today's video, we're going to be going through some of the hardest physics questions that I could find. So this is from last year's paper, and we're going through all the questions where students really struggled, and statistically, students did the worst. Okay, so feel free to follow along, see if you get these questions right, where a lot of students did go wrong. So 50% of students actually get this question wrong. They get 0 marks on this question. It's out of 2. And the question seems quite straightforward when you look at it. The braking distance of the car increases as the speed of the car increases. Give 2 other factors that increase the braking distance of the car. So go ahead, pause the video. I'll give you a chance to have a go at it. What would you write down for 2 marks here? So let's go through the answer. And the reason why most students actually get 0 marks on this, and let's see if you fell into this pitfall as well, is not because the question was too challenging, it's because they didn't read the question carefully enough. So the first thing is 2 other factors. So it's already mentioned one factor, the speed of the car increases the braking distance. You can't mention that as another factor. But one thing that you should know is that in bold over here, it says factors that increase the braking distance of a car. So you can't just say the factor, you have to specify what you would do to that factor to increase the braking distance of the car. So what does that mean? Well, let's have a look. For example, you couldn't just say road condition. Okay, so if you were to write road condition over here, seems like a sensible answer for this question. Perhaps some of you put this down as one of your answers, but this would actually be wrong. Okay, you wouldn't get the mark here. And the reason for that is that the road condition alone, that's not enough information to say that the braking distance of the car would increase. If the road condition was bad, then you could say the braking distance of the car would increase. If you said it was wet or icy, they would all count towards the mark. But for example, the road condition could be a really good road condition, and in that case, the braking distance would actually be decreased. So to get the mark here for that kind of factor, you'd have to say a wet or icy road, or you can maybe say poor road conditions, something like that. And a similar thing for the second mark, perhaps you could say worn tires. Okay, so again, you wouldn't get the mark if you were to say tire condition, because that's not enough. The tires could be in good condition, and that would decrease the braking distance of the car. So you can see this question is just a little pitfall that students fall into. You don't read the question carefully enough. I'd always recommend, as you go through the exam, underline the keywords so you don't forget when you're answering your question. All right, question 4, another one where students tend to struggle. So a lot of students got this question wrong, or they dropped marks here. The question is about hailstones. It says they're small balls of ice and they're formed in clouds and fall to the ground. Okay, we're not so interested in that bit. But the idea is here, the hailstone falls from a cloud and accelerates. And 4.1 seems like a nice easy 1 marker. Why does the hailstone actually accelerate? But the key here is actually to understand what causes acceleration. And there is only one thing that you could put here. So go ahead and have a go. So it's a 1 marker, so it should be an instant answer. But actually, you have to say that there's a resultant force. Okay, so you should hopefully all know the link between resultant force and acceleration, where F equals ma. But F here, even though we write F in our equation, it's resultant force. It's not just force. So you can't just say there's a downwards force on the hailstone. If you were to say there's a downwards force, it wouldn't be enough marks, because yes, there is a downwards force, but there's also air resistance. So if you were to draw out the hailstone, it would look like this. There would be a downwards force, sure, that would be the weight, mg, sure, but you'd also have a force of air resistance acting on the hailstone. And if it accelerates when it's going downwards, so that means that this force is larger, i.e. there's a resultant force downwards, okay? So why does the hailstone accelerate? Because it's a resultant force, not just because it's downwards. And actually, the second part of the question, a lot of students still struggle with as well. Around half the students here scored 0 marks. Okay, so let's see if you guys can get this one right. The hailstone stops accelerating and reaches terminal velocity. Explain why the hailstone reaches terminal velocity. Okay, so it's 3 marks. Even if you don't get all 3, you would expect students to get more than 1. Okay, so have a go. What would you write for 3 marks? Try to lay out your answers so you've got 3 distinct points, which are all going to score a mark. Okay, so to start off with, for your first mark, then what you can say, as the velocity of the hailstone increases, what actually happens is the air resistance also increases. Okay, so remember, it's 3 marks, so you've got to lay it out. So that's the first kind of step that you reach when you start to approach terminal velocity. Okay, what's the next thing that happens? We already know it accelerates, so we don't need to say that it accelerates, and therefore we know the air resistance increases. Now, does the air resistance increase forever? No. What's the next logical step that happens? The air resistance increases until the air resistance becomes equal to the downwards force, which is, in other words, the weight. Okay, so remember, if you look at our diagram, we had 2 forces, the weight and the air resistance. So when you reach terminal velocity, these two have to be equal. Okay, your weight, or your mg is what we labeled it, has to be equal to your air resistance. So the air resistance we know increases as the velocity increases, as you accelerate, until you get to this point where the air resistance is equal to the weight. So you have to say here until. So this is kind of the second step. Now you need to explain what happens here. So in the second step, when the air resistance is equal to the weight, how does this mean it reaches terminal velocity? Well, the logical next bit of that is that the resultant force is 0. And if you got the first question right, then you would know to write about the resultant force. So it kind of links together. So here, the air resistance is equal to the weight. Therefore, the resultant force becomes 0. And as a result, because we just written up there that the resultant force is what causes the acceleration, that is enough for your third mark, okay? So you can see you don't need a lot of writing, to be honest. Obviously, I recommend you write it out, not just write it in these kind of symbols like I have done. But actually, it's 3 points, it's 3 marks. And if you know how terminal velocity works, then you should know those 3 distinct steps, okay? First of all, you're accelerating, your air resistance increases until you get to the point where the forces are balanced. And at that point, there's no resultant force, and therefore you have no acceleration. And we'll do the first 2 parts of this question as well. So as question 5, we've got some tomatoes on a balance here. It shows you're measuring the mass of 5 tomatoes. Okay, great. So 5.1, we'd expect students to get this right, but actually a lot of students did actually struggle with this. And actually only about 25% of students managed to give the correct definition here. So let's see if you can have a go and get the mark here. Is 1 mark what is meant by the center of mass? So can we define center of mass? So this is a question that you guys should just memorize. You should memorize the definition of center of mass. You should understand it, but you should also memorize the definition so you can give the correct definition in the exam. So what would you put? Well, the correct definition for the center of mass should actually be the point from which the weight may be considered to act, okay? Or you can say the point where the mass appears to be concentrated. And either of those definitions would give you the mark. Now, if you didn't memorize that definition, you might struggle to actually correctly define it. A lot of students might say it's just where the most of the mass is, but again, that's not correct. Or you might say that is where the center of the object is, but again, it's not correct. So in a tomato, for example, or if you have a group of tomatoes, you have 3 tomatoes, they all weigh the same amount. So they all weigh 1 kilogram each. So the idea is the center of mass of the tomatoes, where would it be? Well, if we just look left to right, where would the center of mass be? It would be in the middle, okay? Now that's not saying that all the tomatoes weight is in the middle, and it's not saying that most of the tomatoes weight is in the middle. You can see there's only actually 1 kilogram of weight of the tomato in the middle, and there's 1 kilogram on the left, 1 kilogram on the right. But the idea is if you were to try to work out where the average of the mass is, then it would be in the middle, okay? Or you can think about where the mass appears to be concentrated, it would appear to be concentrated in the middle, okay? So 5.2, again, a lot of students did not do so well on this question. Only about 20% got the full 3 marks that are available here. And so you guys go ahead, pause the video, see if you can figure out what the method is to get all 3 marks, see if you drop any marks, okay? And I'll just scroll up and we can go through it together. So this is the diagram that we're working off, and the question asks us calculate the mean weight of a tomato in figure 9 using physics equation sheet. And so you need to use your diagram for this, okay? So it tells us there's 5 tomatoes and there is a reading, but it doesn't tell us the reading, it just shows us it in the diagram. So what you need to do is you need to come along to your exam paper and look what is this reading actually, what does it actually say, okay? So the reading is somewhere between 400 and 500, so you need to work out what each graduation is worth between 400 and 500. Now between 400 and 500, there's 1, 2, 3, or 3 lines, or basically 4 gaps, right? So there's 1 jump, 2 jumps, 3 jumps, 4 jumps. So because there's 4 jumps and the difference is 100, then you know that each jump is going to be worth 25, okay? All you did was 100 over 4, each jump has to be worth 25. So now using that information, you should be able to read off very easily what 5 tomatoes in this case weighs. So it's 400 and it's 1 jump, so it's 425 grams. And that's equal to 5 tomatoes. We'll just write 5T for short. Okay, great. So if 5 tomatoes weighs 425 grams, then you need to say that, well, what does 1 tomato weigh? So you just do 425 divided by 5, and you should get an answer of 85 grams. 85 grams. And if you go back to our question, it's asking us what's the mean weight of a tomato. So here's the thing, right? What we just worked out was the mass, and I'll write it down here. So 85 grams is the mass of 1 tomato, okay? Now, again, this is an average weight because actually each tomato might weigh differently, but because you've got 5 tomatoes, when you divide through by the total number, you get the average. So this is the average, and I said weight there, but actually this is the average mass, okay? And how do you convert mass to grams? Well, it kind of gives you, mass to weight. Well, it kind of gives you the equation in the question because it says the gravitational field strength is 9.8 newtons per kilogram. So for every kilogram you have, multiply it by 9.8 and you'll get how many newtons that is, or that's how you basically transfer from mass to grams. So we take this 85 grams, and because our unit is here in kilograms, we need to convert it to kilograms first. So 85 grams in kilograms is 0.085, divide 3 by 1000. Then you want to multiply that by the 9.8 that were given in the question. And if you do that in your calculator, you should get an answer of 0.8333 newtons. Okay, and you can write that down in there. And that's basically it. So it seems fairly straightforward, but actually a lot of students did get that question wrong. So how did you guys do? Okay, moving on to 7.3 of the same paper. Now this question, only 10% of the students who did this question, only 10% of them got any marks. So it's worth 3 marks, and 90% of students didn't get any marks over here. They scored a big 0. So you guys go ahead, pause the video, have a go. There is some background to this, but essentially it's an explain question. Explain why there is an alternating current in the output when the transformer is connected to a circuit. And so I'll scroll up so you can see what they're talking about. We've got a transformer here. If you connect this to a circuit, why do you get an alternating current? And it's worth 3 marks. So what would you write for 3 marks? Have a go. Okay, so this question, or forms of this question, do come up a lot in exams, so you need to be well prepared. It's all about transformers and the function of transformers, and you need to be able to explain it step by step. Depending on how many marks question is worth, you need to put enough points and enough detail to get all the marks. So let's actually have a look at the transformer here. If you connect this to a circuit, why would we get an alternating current in the output? Basically, that's the question, okay? So in the first step, what happens when we connect this current, okay? Well, we have an alternating current at the input, okay? So this is the first thing you can say. And the alternating current causes a changing magnetic field around the primary coil. So you've got 2 coils here. This is the primary coil. This is the secondary coil. And when you have this alternating current, first of all, is just through this primary coil. So look, if you look at this circuit, it's not connected. There's no connection over here. There's no wire over here. So all that happens when you connect this up, the input, is you have your alternating current winding around this coil, and what that produces is an alternating magnetic field. Okay, you can say a changing magnetic field. I'll just write MF for short. Now the key is it's a changing magnetic field, and it's around the primary coil. So you need to say specifically it's around the primary coil, not the secondary. Now the reason why you get a changing magnetic field is because you have an alternating current in the first place. Okay, so this is the first step, and if you write that down, you get 1 mark. What do you need to write for the second mark? Well, this alternating, or this changing magnetic field in your primary coil then creates a changing magnetic field in the core. So the core is this big metal block over here. There's the core. And what happens is you have a changing magnetic field around the coil of your wire, and this causes a changing magnetic field in the core itself. Now you can see where this is going because the core is connected to the secondary coil. Both cores are wrapped around it, okay? So now the changing magnetic field is basically able to flow through your core, and it reaches the secondary coil. And when it reaches the secondary coil, this induces an alternating potential difference across the secondary coil, okay? So then you end up with alternating potential difference around the secondary coil. And in turn, that produces an alternating current, okay? So that's basically all you need to say for the 3 marks. If you know the steps, it's quite a simple question to answer. But I guess a lot of students were not aware of the actual step that goes into how a transformer works, okay? So let's summarize it now. I've taken the diagram off the screen. What's the first thing that happens is you have an alternating current, and this produces an alternating magnetic field in the primary coil. This results in what? Well, it creates a changing magnetic field in the core. And you can be more specific here. You can say what's changing about this magnetic field. Specifically, it changes direction, okay? And again, this is as a result of the alternating current in the first place. And then the last step is, well, now you have a changing magnetic field in the core. So then this goes to the secondary coil and it induces, and you need to say induces. Okay, so in the mark scheme, you have to say these specific words. You need to say primary coil over here. You need to specify as a primary coil. You need to specify the change in magnetic field goes into the core, and then you need to say this induces an alternating potential difference. Just induces is fine. Alternating potential difference across the secondary coil. Okay, and basically when you have an alternating potential difference, then you also get your alternating current. Okay, so that's what you need to write down for 3 marks. Hopefully it seems fairly simple when you lay it all out like that about the function of a transformer. Okay, this is the last question we're going to cover in this video. Essentially, we have a question about upthrust. So diving bricks sink to the bottom of a swimming pool. Figure 14 shows a diving brick. Swimmers practice diving to the bottom of the swimming pool to pick up the diving brick. Explain why the forces on the brick at the bottom of the pool cause the brick to be stationary. Okay, so essentially, why would anything be stationary? And again, look at the marks. It's 3 marks. So have a go. What would your answer be to get all 3 marks? Okay, so it's worth 3 marks, but it's actually useful to actually understand if you work almost backwards a little bit over here. So the question is asking us why the brick would be stationary. Now, if something is stationary or moving at a constant velocity, that means that basically there's no resultant force. Okay, so resultant force equals 0. So when we're going to answer this question, is because it's worth 3 marks, basically our answer needs to be in enough detail to explain why the resultant force on this brick is 0. Okay, so let's think about the forces that are actually acting on this brick. Now, when the brick is at the bottom of the swimming pool, there's 3 forces. Okay, remember it's at the bottom, so it's touching the bottom of the pool. So there's going to be a normal contact force. Okay, so this force, as a lot of students might leave it out because you might not read that it's at the bottom of the swimming pool. But this is the key, right? It is at the bottom, and you need to include the normal contact force. Whenever something is resting on a surface, there's going to be a normal contact force, and it's going to act at right angles, hence the name normal. Okay, so then let's actually plot the other forces that are acting on the brick. Now, also acting upwards is going to be the upthrust. Okay, so there is still upthrust, even though the brick is on the floor, it's still submerged in the water. So there's still going to be this upthrust from the fact that it's in water. And again, it acts upwards, as you might expect. And the other force, hopefully everyone should get, is the weight of the brick itself. Okay, so we can write on weight there. So that's our annotated diagram, but what do we need to write for the 3 marks? Well, the first thing is basically all you're doing is explaining these forces. Okay, so you say the upthrust acts upwards, then you have the normal contact force also acts upwards, and you can also say the weight acts downwards. But basically for the 3rd mark, what you'd say is that the weight, which is acting downwards, is equal to the forces that are upwards. So the upthrust plus the normal force. Okay, so when you write all of that, or worse to that effect, basically you should get all 3 marks. Okay, so that's the last question we're going to do. This was just a selection of questions, and these are all basically from the June 2022 paper. We went through the questions that students found generally most challenging. If you found this kind of video useful, let me know, and we'll see if we can put out part 2, going through more papers and just focusing on the questions where a lot of students dropped a lot of marks. Okay, but I'll leave it there then. Happy revising and good luck with your exams.